In this pod, we'll look at how you investigate the output of an iron cored transformer.
Transformers are used to step up or step down the voltage from an alternating current or AC supply. For instance, electricity generated for the national grid is often produced at 25,000 volts. A step-up transformer increases the voltage to 400,000 volts to send it through the national grid. A series of step-down transformers then decreases the voltage down to 230 volts when it reaches our homes. These transformers consist of a laminated iron core with two coils wrapped around the core. These are known as the primary and secondary coils.
The alternating current in the primary coil induces an alternating magnetic field in the iron core. This then induces an alternating current in the secondary coil. The AC voltage in the secondary coil depends on the ratio of the coils. More formally, the number of primary turns divided by the number of secondary turns equals the primary voltage divided by the secondary voltage. In symbols, this is N1 divided by N2 equals V1 divided by V2.
To investigate this in a transformer, you will need the following: an AC power supply, AC voltmeters and ammeters, two C cores and a clip to form a core, two 2.5-volt light bulbs, copper wires with bared ends, and enough insulated wire to wrap around the coils.
Let's walk through the setup process now. Start by winding 10 turns of insulated wire around one C core to form a primary coil. Then wind 20 turns of insulated wire around the other C core. This forms the secondary coil. Clip the two C cores together to form a transformer. Connect the ends of the secondary coil to one of the bulbs. Connect the ends of the primary coil to the AC terminals of the power supply, with the output set at 1 volt. Connect a second bulb in parallel with the power supply.
Switch the power supply on and note the brightness of the two bulbs. The bulb connected to the secondary coil should be brighter. Insert AC ammeters or multimeters in series between the bulbs and the ends of the coils, and check the current in each circuit. Make a note of your readings.
Using the multimeter or an AC voltmeter, check the voltage across each bulb, both primary and secondary. Make a note of your readings. You can keep repeating the experiment using different ratios of coils for the primary and secondary coils. You can include having fewer turns on the primary than the secondary coil.
Enter your results in a table with headings as follows: number of turns on the primary coil, number of turns on the secondary coil, voltage in the primary coil, voltage in the secondary coil, current in the primary coil, and current in the secondary coil.
You can now work out the power in the primary coil and the secondary coil for each transformer you build. Power is found by multiplying the current and the voltage, or P equals I multiplied by V.
Look at your results table and make some comments on your findings. The power columns at the end may be interesting. Include this in your conclusion and suggest a reason.
Finally, some safety advice. Remember that during the investigation, it's important to ensure that the coils are not overheating. If this happens, switch off the power supply to let them cool down.
Your conclusion will likely find that if there are more coils on the secondary coil than the primary coil, then the voltage increases, the current decreases, and the power stays the same. This is a step-up transformer. If there are less coils on the secondary coil than the primary coil, the voltage decreases, the current increases, and the power stays the same. This is a step-down transformer.